Right, so we have our classic non-inverted operational amplifier setup. So we are going to the application we are going to look at is the something called the voltage follower, right? Just a reminder about the setup of the typical non-inverted operational amplifier. Single input Vin is fed into the non-inverted input terminal, right? There is still negative feedback via RF from the output voltage to the inverted input terminal, which is grounded via the resistance R1, right? We examined the closed loop gain in our last class. Closed loop gain of this amplifier here is 1 plus R feedback divided by R1, right? So to create a voltage follower, what I'm going to do is I'm going to modify the circuit in two ways. First of all, I'm going to take out the resistor RF and I'm going to replace it with a conducting lead. So I'm just taking it out and I'm putting a conductor there, right? Of course, in the ideal case, the conductor has zero resistance, right? So practically what I've done there is made the value of RF 0. So the first things first here, RF becomes 0, right? And I'm going to do another modification, and that modification involves removing the resistor R1 completely. I'm not going to replace it with anything. I'm going to take out the resistor R1 completely, right? Now, if I do that, I'm not replacing it with anything. So I'm basically creating a break in that portion of the circuit there. So the resistance of that branch that was coming from this node here all the way down to ground, that there is now infinite resistance. So RF becomes 0 when I replace it with a conducting lead. And if I completely break that bottom portion of the circuit, I have essentially made R1 an infinite resistance. Good. So if I go and I put those two things into my closed loop gain equation of the non-inverting operation amplifier, the closed loop gain becomes 1 plus 0 over infinity. And of course, this whole thing here just becomes 0. Good. So your closed loop gain in that case now becomes 1, right? So that closed loop gain of 1 means we call this circuit by another name. This is what you call the unity gain, because the gain is 1 buffer. And I'll explain the reason for calling it a buffer afterwards. So that's a unity gain buffer. It's this operational amplifier circuit here configured to have a gain of exactly 1, right? Now we made reference to unity gain and so on before. We didn't discuss the actual configuration, but we spoke about unity gain bandwidth and so on before, right? Now, so if I look at the transfer equation for this particular circuit now, of course, V out will be closed loop gain multiplied by V in. And if your closed loop gain in this case is 1, this would mean then that V out. So closed loop gain is unity. So that means V out is equal to V in, right? So the output here matches, that is, follows the, we just create a little space here. I want to put in a word that will help my reference a little bit. So the output voltage matches, that is, follows the input voltage. Hence the name voltage follow. Right now, what is the purpose of a voltage follower? Because you might be wondering, well, if you already have that same voltage V in, what is the purpose of matching it and just having the same output voltage V out, right? And so therefore I would like to also explain, incorporate into my explanation here why they call it a buffer, right? Right, so let's talk about the application of the voltage follower itself. So let's say you have a high impedance circuit, and then you have a low impedance circuit that you need to connect together, right? Now the low impedance circuit is one where currents and so on will affect its operation, right? So if you take that low impedance circuit and you connect it to the high impedance circuit directly, the high impedance circuit would act in such a way that it would load that secondary circuit, that low impedance circuit, right? Now you do not want, let's say you do not want the high impedance circuit to affect the operation of the low impedance circuit, right? So you just want to connect them in such a way where they are sharing voltages, let's say, or you want to have your low impedance circuit matching the voltage of the high impedance. What you don't want to connect them directly together, because the output of that high impedance will affect the performance and the behavior, the operation of the low impedance. So the voltage follower now is used to basically to isolate those two circuits in terms of power transmission, but yet still have them connected in such a way that you could share a signal between these two circuits here. So what you would have now is your output signal from your high impedance circuit will go to your voltage follower. Let's put VF there for voltage follower. And then that same signal there will be transmitted to your low impedance circuit. So what you have is you have an isolation in the voltage follower. That is, you have an isolation of input and output, right? All it does is matches the input signal. It does not transfer any power itself from the input terminal to the output terminal itself, right? So you would have your high impedance circuit sending a signal to the voltage follower, and that same signal is sent to the low impedance circuit, but no power is transmitted from the high impedance to the low impedance. So they are still isolated in terms of power transmission from each other, but yet still you are able to transmit a signal from the high impedance circuit to the low impedance circuit itself, right? So that is the use of the voltage follower. It is used to buffer two circuits, right? Um, the another important feature of the voltage follower itself is it matches basically every aspect of that output signal, right? Of course, it matches the voltage, it matches the frequency, so you could use it for basically any frequency signal, and so on as well. It immediately produces an output whenever there is any input itself, right? So any change to its input, that is any change to the high impedance circuit, could be immediately detected by the low impedance circuit itself, right? So that is the use of it for signaling purposes, while isolating them in terms of power transmission itself, right? Now, if you do need to have power amplification, the voltage follower could do power amplification as well, but the output power itself will come from the power supply connections of the voltage follower rather than the drawing power from the input itself, right? That is, it will draw its power, if necessary, from the voltage follower connections rather than drawing power from the high impedance circuit that is connected on the other side, right? So that is basically all we have to say about the voltage follower.